Hello, this is Darren Pulsifer, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, Advanced Comms on the Edge with Dr. Anna Scott and Leland Brown.
Hi.
Anna, Leland, welcome to the show.
Hey, Darren, thank you.
You are both not newcomers. Leland, you've been on the show twice now, and Anna is a regular now. And Leland, you're our technical director of Advanced Comms at Intel. And those of you know Dr. Anna Scott, she's our Chief Edge Architect for Public Sector at Intel. Guys, it's always a pleasure to have you on. Normally, I'd say introduce yourselves, but everyone already knows you.
Well, hey, I'll tell you, Darren, as like I said the last time, you're one of my favorite people to work with at Intel, and now you have another person I'm always love to work with, Anna Scott. So this would be a great time for me. Looking forward.
It is. So
Yeah,
let's start off by talking about the history of advanced communications in general, right? I mean, I don't want you, Leland. You're the man here when it comes to advanced comms. Let's not go all the way back to the telegraph. But let's go back. Let's take a little step back.
Okay, great. So, when you think about cellular technology, I mean, if you want to talk about communications and what's really when someone thinks of communicating now, they're not thinking about a phone on their desk, or some type of head unit device on their desk, like an old bell phone. They're really thinking about a cell phone. So where did that start? We're going back to maybe very late 70s, early 80s. We got into something called AMPS, Advanced Mobile Public Service. I believe it was AMPS had stood for around 81. If you had the ability to make a voice call, you were the greatest person on the planet. If you could sit in your phone, sit in your car and make a call, like you were like the coolest person running around. I actually had a bag phone in my car when I was in my early 20s, and everybody thought I was rich. And no, I wasn't rich. I just got a bag phone. It was like a cell phone in a car. But
did you wait, Leland? You got to back up. Did you milk that? I hope you milked that.
Oh, I milked it hardcore. Yeah. I mean,
all right, good. I just want to make sure, man.
Oh, yeah. College and everything. It was like, man, what's going on? But, it was really, if you were able to make a call, that was like the greatest thing I could call. Now, of course, as luxuries once tasted, become a necessity. So the necessity to make a call and a requirement to make a call on a cell phone became the foundation. And if you couldn't make it, as things went on into what we call 2G, which is more of our time division, multi-access type of technologies. I think GSM may have kind of kicked in around that time period. You were getting more into, well, can you text? Can we make phone calls and text? Maybe early 90s time period when 2G was starting to really kick in. And of course, again, that became a necessity, call, text. Okay, maybe playing something on the phone, where phones went from just making phone calls, they turned into devices. Maybe you can do a little bit of games. The game called Snake. I don't know if anybody remembers.
Oh,
Snake
yeah, I was good at Snake.
Yeah, you know what I mean? That was really the time period where 2G was starting to turn the phone into something a little more than dialing buttons and making a call. Then you got into 3G, and 3G brought on the ability to do some nascent data capabilities. What I mean by that is the internet was in its early stages, late 90s, early 2000s. Can you do the same thing on a phone? And you want to talk about cool? I actually had a phone. It was a flip phone, or what we call a clamshell phone, where I found the ability to take a dongle, connect it into my PCIe slot on my laptop. And if you typed in #777, it gave you direct access to Sprint's data network. And from there, I was able to have my laptop be a mobile, device. Now, we actually take advantage of Wi-Fi nowadays. That did not exist back then. So it was really cool. I mean, believe me, I was dating at the time. I would give a girl, hey, you want to do your work? Say, how can I do that? Hey, I got you hooked up. So, it it was really cool. But think about it. That was very, I mean, very minimal. I mean, maybe DSL speeds, if that, modem speeds really. uh, that I was able to manipulate the system to give me data only calls. Now we take for granted nowadays what this phone can do. You know, we we take it for granted. You know what smartphones can do. Back then, it just didn't exist. Now after 3G, we transitioned into two areas of scope: a unified standard, meaning back then you had CDMA, Qualcomm, you had GSM, you know, and you had the carriers back then that existed, Sprint and at the time maybe Bell Atlantic, or probably just starting to turn into Verizon more on the CDMA track. You had T-Mobile, you had AT&T on the GSM track primarily. 4G converged it into one LTE under 3GPP. Okay, that evolved standard turned where every carrier started to adopt, you know, a common standard across the board. Now we can talk about WiMAX. That's a whole nother long term discussion. Everybody went to LTE primarily, and that's when you saw the proliferation of broadband. If you think about companies like Amazon, Netflix, Uber, all of the platforms, YouTube, Google, um, Facebook, everyone that are common now for us, you take away the smartphone, you take away broadband in the hand, will not exist at all. I give 4G the credit for really proliferating the advancement of our economy through the 2010s. Without 4G, I don't see it really happening.
Okay, so now 4G's been out for a long time. 5G, everyone has 5G now, supposedly, right?
Hmm. Well,
So that's where we're at
well,
today is 5G.
so I have a tendency to state this in terms of the carriers and what they've deployed. And anyone that sees this podcast, they may have some discussion points for me about this, but I'm willing to defend it. Uh, 4G and 5G are related. They're a part of the same spec line. Release 14 ends what we call 4G LTE Advanced. Release 15 kicks in what we call 5G NR, right? And that crossover, if we really think about it, there's a business objective there, and there's also a strategy to try to adopt a new technology as a part of the standard. The business objective is a lot of companies have already invested into their 4G networks. So the current evolved packet core and the current RAN components of the 4G network are still in place. You're adding in our 5G RAN box that has a different frequency but still connected back to the 4G core, something that we call non-standalone. Okay.
So it wasn't so 5G. From correct me if I'm wrong, because I may be completely off. But 4G was revolutionary
Hmm.
because it really unlocked and it required new equipment, completely new equipment, new standard. 5G is more evolutionary,
I
but
agree.
it unlocks a whole bunch of new things. But the underlying technology is based on the same type of hardware, same core.
The, the underlying technology is based upon the same standard. I mean, example, instead of
Okay.
having a bandwidth of 20 megahertz within your air interface, 4G gives you 100 megahertz bandwidth. There's parts of the modulation scheme that 4G provides, and I'm sorry, 5G provides in the air interface. But the architecture is different, is virtualized under 5G as compared to more proprietary under 4G. Uh, and that leads to a lot of capabilities that you're starting to see uh, become a part of the 5G deployments. One example, you know, I like to give: when a carrier deployed a 4G network, they deployed it by putting a RAM box right next to an old 3G box. 4G, I always told, was a data network that you can now have voice as a part of the data session. And a lot of companies kept their 3G boxes. Like Sprint for years kept their CDMA network up. I think they just turned it down once T-Mobile had purchased them. But in reality, 4G was just another box sitting next to the 3G box.
Gotcha.
5G takes that proprietary box and it gives you the ability to spread the functions of that box across a virtualized network function, meaning what is a part of what we call the baseband of 5G can now be software defined and scaled to multiple areas as compared to being contained into one site or one box or one
So that
location.
means I can add new functionality to my network without
Yes,
going out and replacing hardware. That's what I just heard.
you can, but as you go into standalone, okay, standalone networks, it's the term stand alone. Now you can take a 5G network and do something on premise or on site. Example, if you have a skyscraper and instead of depending upon the network coverage from a antenna sitting outside where the core is sitting back at, let's say, the carrier's, switch station, what have you, you can now develop an on-premise network built within that building that proliferates coverage and data services throughout because it's now on-premise. It's standalone.
So the 5G also, it sounds like, helped me privatize. That's not the right word, but it kind of is. I can
Well,
own my own. I can have my own network inside my house. I can have
is it,
my own 5G network inside my building in a shipyard. We've talked about this, Anna.
it
So
def
this opens up a whole lot of new capabilities. Then,
a whole lot of new capabilities, use cases. It enables new players in the space. Okay, we've been used to having two or three strong players in the space for a while now. Throughout the generations, those players have changed. Now we have two or three primary strong players within the U.S. If you go across the world, there's more, of course, but it enables new players to come in. It enables new business verticals to come into this area. It also enables the federal government, the Defense Department, and the like to start to adopt the technology for their own use cases and have more of a flexibility in terms of the adoption as compared to being highly dependent upon the carriers.
okay,
Yeah, and
Anna. I mean, he just set this up for you. Knock it out of the park. He just said, "Hey, we can do anything you want." Basically, how does that affect the edge, our edge architectures?
yeah, it gets pretty interesting. And so one thing that Leland hadn't touched on that also was changed within the same time frame is how spectrum has been managed and allocated.
Right.
So one of the most powerful things we've said is now you've got the ability for new players to come in. We also have all these new on-prem capabilities. But the other thing that is really opening up the world in the U.S. and granted it's a slightly different picture with respect to spectrum management in other parts of the world is we now have the ability to use CBRS spectrum, and there's somewhat of a complex way that they manage that, but there is a non-priority portion of that that you can just use without paying for it, and then there's actually a priority that you can buy if you want to kind of up the assurity that it's going to be there when you need it. That's Navy Spectrum. So as you can imagine, there's quite a few places in the U.S. where you think that you can have that spectrum, use it, and not have too much disruption. And so what we're seeing is some really cool things where large manufacturing facilities are using CBRS spectrum, either working with a major carrier that is not then charging them for the spectrum because they're using CBRS, or working with a new entrant who is just saying, we'll use CBRS, set up a total on-prem standalone network, and now you can use that for everything that you want to do in your manufacturing environment. And so that's a very different model because there are, especially with manufacturing, there are some real advantages to the wavelengths and the complexity of the systems that you can set up with 5G that actually have advantages over Wi-Fi.
I
So
was going
now
to
you've
ask you,
got
why not just do
mass,
Wi-Fi in my fab, right, or in my factory?
and you still can, and there's still some advantages, but what we see is, especially if you're moving really large pieces of metal around, setting up a robust Wi-Fi network can be really, really challenging.
Yeah.
So, if you have the same configuration of your space and you never change that, then go with Wi-Fi 6, especially if the economics work for you. But when you've got a complex environment that you are reshuffling on a regular basis, or like I say, if you do aircraft, right, and you're moving very large pieces of metal around, having a 5G network is very, very useful. I should be super careful and say often what we're still seeing is that 4G LTE is sufficient, and there hasn't been a full-on move over into 5G spectrum because you can use CBRS with 4G as well. So there's still a movement, but a lot of it is like the ecosystem from a user equipment standpoint isn't nearly as developed and doesn't have nearly the options that you have on the
Very
4G
true.
LTE side.
I know you can buy a laptop with 5G.
Mm-hmm.
I've heard about them. I've never bought one. Um, and do you guys think it'll ever get to the point where Wi-Fi and the 5G, or maybe it's 6G, where they'll converge,
Well,
where I can go buy a router myself, like the router I have, in my house for my Wi-Fi 6. Will I be able to buy a 5G router
well, you kind
someday?
of well, you're kind of seeing it now, right? There's a I'll answer two things. I'll get back to Anna's point as well. There's something within 5G that's called fixed wireless access. Um, to be quite honest, Verizon and a couple of other companies are deploying. I think even T-Mobile's doing this, deploying boxes that you can set up in your house and gives you access to their network. It gives you basically Wi-Fi services in your house.
This is
There you
it.
go. That's a 5G fixed wireless
It's
access
a
router.
5G fixed, yeah,
Yeah,
but it's not. It's receiving 5G,
right.
and right,
It's
it's not.
transferring it. Yeah, it's receiving 5G, transforming it into Wi-Fi in your house, and it's
Yeah.
giving you a Wi-Fi
Mhm.
access. I mean,
Do
from a
Do you
standpoint
think
of,
we'll ever get to that point where I'll have a 5G network or a 6G network in my house instead of Wi-Fi, or does that
uh,
matter? I'm
well,
just asking, are they converging or no? They're very separate
well,
use cases and all that.
in many ways, you kind of do have that, right? I mean, let's face it, your house is a multi-domain house. You have 5G coming in, converging into Wi-Fi, right? You also have cellular coming in with your phones. So depending upon how you have your devices set up, you're either on the cellular network directly, or you're using Wi-Fi a through a fixed wireless access point. So it's and also you probably have Bluetooth in your house, right? You probably have some
I didn't
other
know I was
wireless.
so advanced. I'm
Yeah.
I'm super advanced.
But to the point, and getting back to Anna's point around devices, very true. Demand drives change. 4G was nothing wrong with it. I can do broadband on 4G, watch Netflix and everything. I'm very comfortable with it, and I've asked these questions in some discussions in the past. Are you satisfied with your 4G phone? And most people say yeah. So why go to 5G? What is the advantage of the end user to transition over to 5G? I have a tendency to think that 5G's, the value that it brings, isn't necessarily the fact that you get higher data rates and lower latency at the end user point. It's the fact that you can now provide those services at a broad scale across because it's virtualized. The system, or the network architecture, is very software intensive as compared to 4G, which is more proprietary boxes and still based on hardware. I mean, it has software, but it's still based on hardware primarily. This is a software intensive network that can be virtualized and positioned in many places. As Anna stated, the frequency portfolio for 5G is very dynamic. You can utilize unlicensed bands, licensed bands, CPRS. It
So
gives you an
there's more
ability,
more options, a lot
far
more
more
options.
options. Yeah, and I
Yeah.
think that's where you'll see it. If you look at some pictures as to how you compare 4G to 5G, what you see in the pictures is 4G, larger cells, smaller cells, more dependent upon access points covering areas, and then you'll see as a picture with 5G where it'll show similar but underlay of different types of usage points, things, devices that are sharing access. I mean, let's face it, V2X architectures, that was a part of 4G, but a part of that spec was never used. And 5G is heavily used, looked at now as being adopted and deployed because it's virtualized. You're taking away some of the barriers of entry, if you will, to utilizing that part of the spec when you go to a virtualized architecture.
Yeah, very, very fascinating stuff, guys. Thank you so much for coming on the show today. Um, Again, another great episode with you guys. I appreciate your insight. This has been enjoyable.
Hey, Darren, as always, you're one of my favorite people. And then you had Anna. I was not missing this for the world,
Yeah,
man.
I feel the same. This is always exciting, and I always learn something from Leland, and I always learn something from you, Darren. So thank you so much for giving us a chance.
All right, thanks a lot, guys.
Great.
Thank you.
Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and do something wonderful.